Chemical equations. So chemical equations is nothing but in our daily life we see the different type of chemical reactions. So we already know that chemical reactions are so in our part of life. For example, if you take as a chemical reactions in our daily life, for example, our food digestion. I'm going to just cook a food or anything. If I'm going to mix one object in another object, so each and everything is a chemical reaction. So in our daily life, we see the different type of chemical reactions. So around the chemical reactions, I'm going to say that, for example, water is also one of the chemical. Is there nothing but it is a hydrogen and oxygen is mixing in a particular compound, then it will make as a water. So each and everything is a chemical reactions in our body. We are ready to digest the food, and we are ready to just produce energy. Each and everything is just like a chemical reactions. So now today we are going to discuss about the chemical equations, how to identify and what is the meaning of the chemical equations, why we need to just write the chemical equations. So for that we are ready to discuss one activity. So one is a, for example, you just take as a quick line. So quick line is nothing but it is a calcium oxide. So for example, if you take as a calcium oxide is mixed with a water, just in a beaker, you just take a calcium oxide and just add some water. Quick lime you can take and just add some water. Once you touch the glass of the beaker, the walls of the beaker, once you touch it, then what you are going to feel that you feel somewhat hotness. So what is the meaning of this one? Yes, some chemical reactions are going to take place in a particular adding of a quicklime to the water. These are both are different type of compounds. We are ready to add, then it is ready to give us some temperature. Means some reactions are ready to take place. So this is the one activity we need to discuss. So next one we'll go for the another activity. For example, sodium sulfate, Na2SO4. Okay, Na2SO4 sodium sulfate. You just take a 100 ml of water. In a 100 ml of water, I am going to mix sodium sulfate. So then, what does it mean? What is the meaning of that? Sodium sulfate is a solution. Now, when I am going to add water to the particular sodium sulfate, then it became as a sodium sulfate solution. And next one, in another beaker, I am going to add it in a 100 ml of water. So barium chloride, BaCl2. Okay. So barium chloride I am going to add. In this two. Okay, this is a barium chloride solution. Now it became as a, and Na2SO4 is a sodium sulfate solution, right? When I am going to add this sodium sulfate and barium chloride, then what about happening in the particular equation? So Na2SO4 is mixing with a barium BaCl2. So what does that means? It will become as a barium sulfate, and next one is a NaCl, sodium chloride. So Na and Cl both we are ready to just comes to the sodium chloride and barium sulfate. So here this kind of the chemical reactions are ready to take place in this. Then what we are going to think about this kind of chemical reaction means yes. So we need that one kind of chemical reactions are going to appear. The sodium sulfate and barium chloride, these are the two different type of chemicals now. The chemical solutions are ready to mix in together. Then automatically one white color precipitate has to form. So then that is called as a chemical reactions. So sodium chloride and barium sulfate, this kind of the products we are going to get. Okay, so this is the one of the activity. Okay, in this activity, we need to discuss about the 5 ml of HCl, hydrochloric acid. So, take a 5 ml of hydrochloric acid in a particular conical flask or anything beaker you wish. Okay, for example, I want to take as a 5 ml of hydrochloric acid. I am going to take in a particular conical flask. So, in that conical flask, I am going to add the zinc granules, Zn. Okay, So zinc granules I am going to add in a particular hydrochloric acid. Now what kind of reactions are going to take place? So any chemical reactions are going to form, yes or no? Okay. So here now that hydrochloric acid is mixing with a zinc granules, right? The zinc granules are ready to mix with a hydrochloric acid. Then what kind of products we are going to get it? So here that ZnCl2 zinc chloride form as a zinc chloride, and next one is the hydrogen gas is evaluating from it. Okay. So what does it mean? How to identify whether gas is releasing from a particular conical flask or not? You can bring a one lightning matchstick. You can bring a lightning matchstick, just keep near to the above of a particular conical flask. It will give a pop sound and it will stop firing. That's why hydrogen is right to stop the firing. Okay, so hydrochloric acid is mixing with a zinc granules and it became as a zinc chloride, and hydrogen gas is evaluating particular conical flask. Means it's nothing but in a chemical reactions we are right to see that hydrogen gas is evaluating. So identify, you already know that just now I said that you can bring a matchstick, you can just keep above the conical flask. So this is one of the chemical reactions. Okay. So after completion of this one, chemical reactions, and so what is the use of the chemical reactions and how to write the chemical reactions? Now I am going to discuss about that. Chemical equations. So what is the chemical equations and what is the pronunciation we read to just chemical equations? See here, this is a gives. So this left side all are reactants, what we are ready to mix in a particular ratio. For example, this is a calcium oxide is mixing with a water. This kind of all are ready to call as a left side things, all are called as a reactants. So then next one, what about the right side values? Right side what we are going to get, that is called as a product. So product is nothing but after mixing of a reactants, what kind of the ratio will mix, then according to the ratio only will get the product. So this is a right side product, right side value is the product. So we know that, and why we need to just write the chemical equations? If any reason is there to write the chemical equations? Yes. So we have one reason is there to write the chemical equation. If you write the chemical equation, then within fraction of or within one line only we can give a statement with a particular chemical proportions. For example, so here once you see that calcium oxide is mixing with a water, then calcium hydroxide is a CaOH base 2 is right to make. So this kind of one single line can provide the total information about the chemical equation, chemical formula and everything we can providing. And after that, this is actually called as a skeleton equation, whether it is a balancing or not. So balancing is nothing but left side and right side, both values are equalized, then only it is a balanced equation. Then next we are going to discuss about the balancing equations. So in a balancing equation, I am going to write the one chemical formula, then chemical equation I am going to write. For example, hydrogen is there, H2 is mixing with a oxygen O2. So then this gives to the, what is the product? H2O. Water we are going to use that is a H2O is a chemical compound, right? Now hydrogen and oxygen both are mixing. Listen, we should not change any ratios of the particular elements. For example, hydrogen is a 2, oxygen is a 2. Then we should not change this kind of the below values, means that the ratios we don't want to change. Then here this is called as a skeleton equation. Just once you observe this kind of the hydrogens are 2 hydrogens are there, and right side also 2 hydrogens are there. It is a balanced, only hydrogen purpose. The next one will go for the oxygen. Oxygens are 2 are there in a, so right side in a product we don't have that kind of 2 oxygens are there. Now how to balance are there? This is called as the skeleton equation. It is an unbalanced equation. Now we need to balance it. For example, once you see, if you just take as a LHS, RHS. Okay, LHS, RHS, hydrogens and oxygens. So then see here, the hydrogens are LHS 2, RHS side is also 2. Oxygens are now LHS side is a 2. or is side is a 1. This is a mistake. Now we need to just balance it. So simple. Then here if I am going to take as a H2 plus O2, again I am going to write the balancing equation. Then here H2O, here I am going to write. Then here 2 hydrogens are there, 2 oxygens. 2 hydrogens, only 1 oxygen is there. If I am going to keep it 2 here, the 2 value is a product now. So 2 value is applicable to the hydrogen as well as oxygen. That's why 2 2s are 4. 4 hydrogens are there here and 2 oxygens are there. Oxygens are balanced, but what about the hydrogen? Yes, now hydrogens are unbalanced. That's why I am going to change as a, here also I am going to keep as a 2. That's why 4 hydrogens and 4 hydrogens. 2 oxygens and 2 oxygens will be ready to present. This is called as a balancing equation. This is a balanced equation. So if you balance the remaining equations, you can easily to balance it. Now see here C3H8 plus O2. So gives to the CO2 plus H2O. So these are the left side and right side reactants and products also there. Now I want to balance it. It is a skeleton equation. It is an unbalanced equation. Just I am going to verify whether it is a skeleton equation or not. Then carbon's left side is a 3 and carbon's right side is a 1. The next one, hydrogens are 8 hydrogens are there in a left side, but right side the 2 hydrogens only present, and oxygens are 2 here left side and hydrogens are 2 plus 1 is a 3 hydrogens are, oxygens are present in a right side. So this is definitely we can call as a unbalanced equation or skeleton equation. Now we balance it. First of all, I want to use that C3H8 again. One more step I am going to write. Okay, so carbons I want to balance it. Okay, so oxygen, right. So carbons I want to balance it. That's why how many are there? 3. So here also I am going to change as a 3. So 3 CO2 plus H2O. Carbons are balanced, but what about the remaining terms? Just we can identify. So here now hydrogens are there here 8. Now hydrogens are 8. Here the only 2 hydrogens are there. So according to that hydrogens I want to change as a 4 2s are 8. Okay, right, good. So some equations we completed, and what about the oxygens are there? Now oxygens, once you see here, in this situation oxygens 3 2s are 6. Okay, so 3 2s are 6 and 4 oxygens. So 6 plus 4, 10. So right side values are 10 oxygens are there, but left side is there only 2 oxygens are there. I need to just fulfill the equation, balanced equation means 5 2s are 10. So that's why 5 I am going to keep. That's why this is the equation, is a balanced equation. Now see that carbons 3 carbons, hydrogens 8, and oxygens 10 and oxygens are 10 in the left and right side. This is a balanced equation. This is a how to balance it. It is a very easy process to get a good marks in your examination. Definitely you can follow it. You will get perfect.